Alright, let's take a look at sketching a rational function where the numerator and the denominator have the same degree. Okay, so we're basically looking at a rational function in the form of f of x is equal to axn plus c over bxn plus d. Okay, and a and b are coefficients, and the degree of the numerator and the denominator are the same. And this is a really useful way of looking at it because this actually has a particular way that we can determine the restriction on the y, also known as the restriction on the range, the horizontal asymptote, because y is equal to a over b, right? So if we were looking at the range here, y could not equal a over b. Okay. Other than that, everything else is basically related to how we analyzed rational and reciprocal functions previously. But this is something that you kind of want to keep in the back of your mind. So I'm just going to show you guys how we do one of these questions, right? And we're going to just kind of go through the entire works here. Okay, so I'm going to start with the domain range. Okay, so the domain and range. So start with the domain. Well, we can understand that the domain is the restriction on the x-axis, or the x values, sorry. And we can understand that the restriction of the x values occurs when the denominator here becomes 0, right? Because you can't have 0 on the base of a fraction. You can't divide a value by 0. Now, in this case, x cannot equal -3. Okay, and the range here is basically y belongs to all real numbers, but in this case y cannot equal, and we use this principle that it cannot equal a over b. Well, a here is 2, b here is 1. We look at the coefficients on the degree, and in this case it's 2 divided by 1, which is at y cannot equal 2. Okay, so keep this in mind. Using this notion, we can determine our asymptotes. The restriction on the x values, the x-axis, or the restriction on the domain here is going to be our vertical asymptote, and the vertical asymptote occurs when x is equal to -3, and the horizontal asymptote occurs when y is equal to 2. Okay, so those are our two asymptotes. Next thing we want to look at is our intercepts, right? So if we're looking at our intercepts, we need to also find our x-intercept and y-intercept. Now the thing about rational functions, if we're looking at our x-intercept, we know that an x-intercept is when we let f of x equal 0. Now the only way we can make a fraction equal to 0, is if the numerator, if this portion here is equal to 0, right? So to do that, we just let 2x minus 1 is equal to 0. I'm going to move the 1 to the other side, so 2x is equal to 1. If I want to solve for x here, x is equal to 1/2. So the x-intercept is 1/2 and 0. Okay, so this is the x-intercept. It's 1/2 and 0. And so that's the x-intercept. And now you also need to find the y-intercept. So you just do the y-intercept traditionally, like the way you were taught, right? The y-intercept here is basically where the graph hits the y-axis, and we know when the y-axis occurs, x is equal to 0, so I'm going to let x equal 0. So f of 0 here is what we're trying to figure out. We get 2 times 0 minus 1 over 0 plus 3, and we get -1 over 3. So f of 0 here is -1 over 3. So the y-intercept is 0 and -1 over 3. Okay, so that is the y-intercept. And now after you've done that, let's create a sketch of our graph, right? We have our vertical, horizontal asymptotes, we have our two intercepts. Let's see what this graph looks like. So I'm just going to generate a grid, right, so we can show our sketch. Okay, so here's my grid. I'm just going to plot these points out. Okay, so we know that one of our asymptotes is the vertical asymptote is -3, so I'm just going to do that in red. Right, so the vertical asymptote is -3, so we basically have, I'm just going to do the vertical asymptote in red. Okay, so here's my vertical asymptote. X is equal to -3 in red. Right, and we have a horizontal asymptote of y is equal to 2. Let's do that in green. Okay, y is equal to 2, so it's going to be somewhere up here. Okay, so it's y is equal to 2. And we also want to plot our intercepts. Okay, so our intercepts here, it looks like we have 1/2 and 0 for our x-intercept. So let's say it's somewhere here. And for our y-intercept, we have 0 and negative 1 over 3. So it's like negative 0.33. Let's say it's somewhere here. Okay, so this is 0 and negative 1 over 3. And using this, we can create a trace. So this is what our function will look like. We follow the confines of the asymptotes. Okay, so you can kind of see that this is what our sketch will look like, and the other sketch will be in the opposite quadrant here. Okay, so that's the idea. Right, and this is going to bring up an important point. So it's very similar to the reciprocal functions, right? So the only real difference here is the way we calculate our x-intercepts, as well as how we calculate the restriction on our range, right? So we use that principle when the degree is the same between the numerator and denominator. Now the last thing we want to do here is let's write down our n behaviors. Okay, so I'm just going to do that here. Right, so the n behaviors, this is really important to kind of understand how the function behaves around the asymptotes, as well as when x approaches positive and negative infinity, right? So let's start with negative infinity. As x approaches negative infinity, as I'm going this way on the graph, right, to the far left, where x does approach negative infinity, you can see that y actually gets closer and closer to this horizontal asymptote here, and is approaching this horizontal asymptote from above, right? So y is approaching 2 from above. I'm going to write this as 2 plus, right? Because as I go this way on x, y is the trace, and you follow down to the trace. Now the next thing you want to look at here is the vertical asymptote. I'm going to approach the vertical asymptote, and you can approach it two ways, right? You can either approach the vertical asymptote x is equal to negative 3 from the left side or the right side, right? Let's approach it from the left side. So if I'm approaching negative 3 from the left side, you can notice here that the graph is extending to positive infinity, right? You can see that graph there. So as x approaches negative 3 from the left side, y approaches positive infinity. The next step here, let's approach negative 3 from the far right side. So this is like negative 2.9999. And you can notice that as I go closer and closer this way, you can see that the trace goes closer and closer to negative infinity. Okay, and the last step here, as x approaches positive infinity, so as I go this way on the trace, right, as x approaches positive infinity, y gets closer and closer to the horizontal asymptote, and in this case, it's approaching 2 from below. So that's the idea, really, right? So this is the end behavior of our rational function. So this is basically some of the characteristics in terms of sketching these rational functions.